an inch or 3 1/3 millimeters. Multi-size collets accommodate fractional, decimal, metric, and non-standard bar sizes. Collets are the preferred method of work holding for bar stock applications, including automatic bar feeding and bar chucking. Powered collet chucks use an internal collet instead of jaws. Collet chucks clamp with a greater force than collets alone. Between center turning is for long work pieces. A tailstock supports the end of the work opposite the chuck or collet. Both tailstock body and tailstock quill may be moved manually or by programmed command to support different length workpieces. Since cutting forces must be limited when between center turning, it is effective to sometimes add a steady rest to support long, thin work. Also, a steady rest must be used rather than a tailstock when working on the end of a long part. For turning shafts, one technique is to use a face driver, a tool with a center point and several driving pins located in a circle, which dig into the end of the shaft. The face driver provides the torque, while a live center held in the tailstock provides support. Unlike chucks or drive dogs, the face driver allows cutting tool access to the full length of a shaft. The direction of cutting is generally toward the face driver to maintain the driving pressure on the pins. Expanding mandrels, also called arbors or expansion collets, grip rotational parts from the inside diameter. A mandrel works well for thin-walled workpieces and allows access to the full exterior of the workpiece. Mandrels are made up of two highly concentric cylinders, an external double-slit sleeve, and an internal arbor. One arbor will support a range of diameters of expanding sleeves. Expanding mandrels or sleeves are manual or power-operated. A magnetic chuck can be used to grip irregularly shaped ferrous workpieces as long as they have one flat surface. Magnetic plates, cubes, or tombstones are also used with milling. On the two-spindle lathe, it is common to mix work-holding devices. For example, the first operation may involve feeding bar stock through a collet, while the back-end work may be clamping the partially machined workpiece in an automatic three-jaw chuck. Several other combinations are possible. Let's re-examine the material contained in this videotape. Work holding starts from two principles: that to machine a workpiece correctly, first, it must be held in a way that guarantees a definite location part after part. Secondly, the work-holding device must securely grip the work in that position against the various forces acting on the workpiece. To meet productivity demands, work-holding devices must be easy to unload, and load, and set up, and tear down. They must also allow cutting tools maximum access to the work while being cost-effective. When clamped shut, work-holding devices should prevent workpiece movement in and rotation about any plane, restraining all 12 degrees of freedom. For part accuracy and operation productivity, it is best to complete as many machining operations as possible in a single clamping. Basic clamps and vices are effective for low-volume work holding for milling. Machining centers may use pallets for work changing, and much work holding is built up on a pallet base rather than the machine table. Traditional clamps and vices used in milling are supplemented on machining centers by mini pallets and multi-vices. Rotary tables and indexers provide access to additional workpiece surfaces in machining centers. Fixturing can range from dedicated fixtures constructed for specific workpieces in high-volume production to fixtures built up from modular elements in low-quantity production. Hydraulic clamping is reliable, powerful, and can reduce work handling or setup times. In turning, work holding must both rotate the workpiece and resist the centrifugal forces. The three-jaw chuck is the most common work-holding device for lathes. It is limited to holding cylindrical work. It may clamp inward on outside diameters or clamp outward on inside diameters. Collets and collet chucks hold smooth-surfaced, small-diameter work precisely and do not mar the work surface. Both work well with bar feeders. Between center turning uses such devices as the tailstock, the steady rest, and the face driver. Expanding mandrels work well on thin-walled parts with through holes. They allow access to the entire exterior of the workpiece.